It's going to be quite a shift. We're going from governance to reverse engineering a weird language, but I hope some of y'all stay. So my name is Alex. I'm a malware researcher at ESET in Montreal, and today I'm here to talk to you about Nim from the perspective of a reverse engineer. First, to get you all up to speed, what is Nim? Unfortunately, it's not this awesomely named chimp. That's not what I'm here to talk about today. I don't want to spend too much time on the language, but I still need to give you some basic information for the rest to make any kind of sense. So Nim is a programming language, a general purpose that allows you to do some systems programming. It's statically typed and compiled. In that crown there is the logo. You'll see it a lot in the next few slides. So why do people like Nim? What are its selling points? The syntax is script-like. It has strong flavors of Python and Delphi. And as we know, Python is heavily used in InfoSec. And let's face it, Delphi is basically just malware. So it's a natural fit for a lot of people. It also comes with a package manager called Nimble. And packages are essentially Git repos with a specific file. So it's really easy to create them and install them. It compiles down to native executables. You don't have to have an interpreter or any kind of VM. And it also doesn't create a very large runtime in the binary. And it works across most major OSs, and it can get cross-compiled. So why do people who write malware or offensive security tools like it? Some of the stuff I mentioned in the last slide is obviously part of it, but there are some specific features. So the programs are compiled down to C or C++ first. This allows you to easily integrate it into your existing processing or coding pipelines if you're using those languages. And speaking of other languages, Nim has an impressive foreign function interface. So you can directly import symbols and methods from like C, C++, Objective-C, and JavaScript. And of course, you can also interact with existing dynamic libraries. So if you're integrating Nim into your existing tool set, you don't have to write everything from scratch. You can just change one bit at a time. And compared to a lot of other high-level languages, it makes it really easy to interact with the low-level OS functionality. So you have a native module that's a wrapper around some of the stuff, and you have more third-party modules like Winim to extend that even wider. And there are already quite a few offensive security projects out there. You can take them, adapt them, change them, or just use them as is. Just to give you an idea of how much of Nim is related to that kind of field, of the top 6 most starred repos on GitHub, 2 of those are explicitly offensive security related. And in the top 50, you've got about 5. Just for a comparison, if we look at the same thing for Python, you don't have anything until about 28th position. And even that's just a collection of payloads. And you get one at the top 50. Only Ruby comes kind of close because of Metasploit. That's in the top 10. But there's nothing else in the top 50. So, of course, these other languages have much wider user bases than Nim. My point isn't that it's the most used for this, but that it's found sort of an ecological niche in offensive security and malware. Where is it used specifically? So among these projects, the most widespread probably is offensive Nim on your right. And that's a collection of tools and programs to accomplish many tasks related to malware, such as memory patching, code injection, network communication, NT analysis stuff. So you don't have to write all of those from scratch. You can just pick and choose, integrate it into existing the tools you're building. There's also a bunch of packers, backdoors, and CNC frameworks. And of course, everyone's favorite framework, Cobalt Strike, now has some Nim implants. But it's not just red teaming. There's also some actual malware in the wild that uses it. We've seen both cybercrime groups and APTs using it. And that last one that just popped up, Mustang Panda, is why I'm here now. Because I've been tracking them for my work for a few years now. And at some time in the past year, they started writing some new Korplug loaders using Nim. And they were even kind enough to give us some samples that had all the symbols in there. So that was really useful. And those loaders are already an example of red team tool, Nim tooling being used for malware. So this, the dinvoke library, is sort of a replacement for pinvoke. That's fine if you don't know what it is. It's a popular offensive library to dynamically load and execute code without using the obvious APIs that are always hooked or flagged. And somebody, of course, made a Nim version. So when I was looking at the code for that sample, it became really clear that they had used this project and modified it. Even just looking at those functions, you can tell what it is that they added. So there's an odd one here. We have 3 snake case names and 1 camel case at the bottom, get hash. And wouldn't you know, there's no get hash in the original project. So this shows that what I'm talking about, taking Nim tooling, isn't just in a hypothetical, it's already out there. But regarding that difference, that case difference, technically it doesn't matter because Nim is weird. This is one of its most baffling features to me. Identifiers, so variable names and function names, are case insensitive except for the first character, and underscores just don't matter. So this doesn't, all of the variables at the bottom, all the ones in the yellow boxes, they're all the same variable. It's a mess. Luckily, I guess, it won't affect you too much when reverse engineering, since it goes through a pass of C or C++, and those are case sensitive. But it's good to know, because if you don't know that, the code can get real confusing. So now let's dive more into the nitty-gritty of what those samples look like. But first, how do you even tell that a binary was created using Nim, since I said it goes through C or C++? Well, this is how Detect It Easy, the famous Packer detector tool, does it. It does the R data section contain the string io.nim or the string fatal.nim? And it's only for Windows PEs. It works, usually, in most cases, because those are left even when you strip the binaries. But I mean, come on, I could just do a string replace, remove those, and it wouldn't get detected. And also, if I compile a Linux binary, Detect It Easy doesn't know. So what else can we look at? There are some telltale function names. So nim main inner, nim main module, but those are removed when we strip binaries. There's also some error strings, and notice the at before. We'll come back to that later when I talk about strings. And Nim binaries always seem to use the same few TLS callbacks. I haven't had time to properly dig into that, so I'm not sure if it's something we can use yet, but it's a way of something I have to do next. All right, now I had all the symbols in there, as I told you, but they were really ugly. Like C++, Nim does some name mangling for package and function names, but uses its own custom scheme because using one that exists wouldn't be any fun. So this at the top is an actual function name from one of those Mustang Panda loaders. It's not so bad. We can kind of read it. My window proc, and then numbers and instance in there. So it's not great still. But much worse are some of the names you get when you use external packages. So that one at the bottom is from a very simple program I compiled to test my tool. And you can read get uint32be, so that makes sense. But the rest, you see some letters, but it doesn't make any kind of sense. And if you guessed that that was hex encoded, sorry, that would be too obvious. So the mangling scheme isn't documented, so this is one of the first times I had to dig into their compiler source code. And I searched through the stuff, and I found this function that's in charge of mangling the names so that they're valid C identifiers. So slashes and periods are converted to Zs and Os because they sort of look alike, as it says in the comments. Uppercase letters and numbers are converted to their decimal representation. So decimal, of course, base 10. Lucky for us, we don't have to deal with variable length because all of those characters fall into the range that can be expressed with 2 digits. Now that we know that, we can reverse the process. So at the top, we have our mess. At the bottom, it doesn't necessarily tell us what it does, but at least we can read it. And for the second example, If we apply the same thing, we'll get this. And this is how I, and probably a lot of you, learned that package names are actually paths for Nim. This can leak interesting information, much like what you could find in PDB paths. So usernames, package version, project names. And here, you can see the exact version and checksum of that Nim SHA-2 package I used, and along with my Nimble installation path. So when you're doing threat intel, this can be interesting information. On the other hand, packages from the standard library use a path that is relative to the base Nim library path. So pure is one of those standard lib package. So that one is pure strutils. And as a little aside, the exact same function from before, I compiled it for both Windows and Linux. And Windows uses an absolute path, Linux uses a relative path, and I do not know why. I can find where in the code it does so, but the reason behind it, no idea. Anyway, mangling problem solved, right? That's it. No, of course not. If we dig a little deeper, we get a whole different set of names like this. Technically, you could read it out, but it doesn't make any sense. So atm.sats. It turns out that module initialization functions are mangled in a totally different way. Again, why? I don't know. I can find in the code, I can find the logic, but the reasoning escapes me. So special characters are converted to a string representation. A slash becomes the word slash, a period becomes the word dot, and then you also use a kind of escaping scheme for some special characters. So you have an at followed by a character, and that indicates what it is. And colons and slashes are covered by both of these, so you can be really sure they're escaped. And also notice that in that case, the module name comes before the function name, and it was the opposite for the other ones before. And consistency must be really boring to these guys because I don't know. And also you get the file extension in the name, so you get the .nim there that you didn't in the previous ones. So remember also how I said that native packages use a relative path? Well, not always, not for those. Well, that was a lot about module names, so I'll just do a quick recap of that part. Nim uses two distinct mangling schemes, both custom. Module names are actually paths, and init functions are treated completely differently from everything else. Now, let's move on to strings, as I promised earlier. So if we go back to our example, you may have noticed those weird _tm and a Blaze64 blob. Those are identifiers, they're temporary names, hence the tm, for various variables. And that name doesn't tell us much. The base64 part is just a hash of some of the module's properties, and the integer at the end is just an incrementing counter. So the name itself isn't useful. But what it points to is often something like a string or another data structure, so they can be really useful. By default in IDA or in Ghidra, those will look something like this. So we've got some numbers, we've got a string at kernel tree 2, but it's not all organized properly. And in Nim, like many other languages, strings aren't just a sequence of bytes, they're actually an object. I'm not here to just show you source code from Nim, so I'll show you with a more visual example. These are the same structures in a simple C-like syntax, and if we apply those to our data, it makes a bit more sense. So we have a length, a field that's the capacity and some flags, and the string content itself. Now we can actually do something with that. We can actually read it. And if we go back to the same example, but we apply everything, we got a proper function name with the packages, we got the identifiers that make sense with the proper fields. There's a lot of other quirks with strings, but I won't bore you with all the details. That was the general case. So after hearing all of this, you might hear like people calling for help, and very geeky joke Rohan cannot answer. Let's look at what might. So I found this old project to generate signatures for libraries. It hasn't been updated in 5 years, so we can just skip it. And of course, there's this plugin that was featured by Hexrays a year ago. So the Nim IDA flirt generator by Holger Unterbrink from Cisco Talos. And it's a tool that will help you generate flirt signatures, so library signatures for Nim functions and libraries. It's really good at what it does. It's a bit of a pain to generate those signatures, but that's not because of the tool. It's just because generating signatures for IDA is an incredibly annoying process and so many manual steps. But that tool is useful, and it's a good complement to use with the one I'm going to talk about that I'm releasing. And that's it. That's everything Nim specific for reverse engineering that I could find. You're going to use a lot of generic tools, but nothing that will deal with those quirks and others I mentioned. So enter my sales pitch for a free and open source tool that we released today. Not selling anything, but it's called Nimfelt, and I'm going to show you what it does. So at first, it was just a simple command line script to demangle method names. I was inspired by C++ filt, hence the name. But once I got more than one of those samples to analyze, it became really cumbersome to have to copy everything over. And there was also all these other weird things I found out. So as I got more samples, the functionality grew. I was inspired by AlphaGolang, a great set of scripts to help with Golang binaries. You can figure out why I was inspired by this because I contributed, so it was on my mind. But I find that using that tool, even though it's great, is cumbersome. You have to run like 5 scripts in a row. And the IDA UI isn't great for that. So now I'm going to show you how it works. I've got a little recorded demo because I am not insane. I'm not doing this live. And I am using one of those actual malware samples I mentioned earlier. So I hope things are big enough. I tried to zoom in, but not every tool allows you to do that. So here I have detected easy. You can see that it is detected as Nim, so we don't have to do anything more. And in PE Bear, you probably cannot read it, but there is our Nim main export. So that confirms it. If we go to IDA, see what it looks like when it's first loaded without running anything special. We have all the weird mangled names in the left column. And we have our exports. I analyzed this already, so I know that this one, the first one, is the one that actually does the malicious payload. And you can see that it uses some strings, and those aren't even recognized as strings by default. So you would have to define them all manually, like I'm doing in this video here. And now that I run the plugin, it's in the menu because it's an actual IDA plugin. You can see on the left that all the functions have been renamed. They're also organized in directories by package. I plan in a future release to make that so that all the packages from the standard libraries are together, all the ones from the package manager are together, but I haven't had time to do that yet. And you can see there that modified deinvoke library I mentioned with our custom get hash. I still have some trouble with those Nimble package names because there's just so many special symbols, but that will be cleaned up in an upcoming release. If we go back to that first actually relevant thing, we can see that those strings are properly typed. You don't see the string content, but that's not my fault, that's IDA. Please believe me. And you can see that some of those variable names haven't been demangled yet. So it's because they're not function names, they're just identifiers. And so that's not supported yet in version 1, but I will try to do something about that because it's annoying to me. So this is the GitHub project. It's been open sourced, I think, 3 or 4 hours ago. So check it out if you have to deal with that stuff. And let's do a quick recap of whatever I talked about today. So Nim has found a following in the offensive security world and among some threat actors. And because of its features and how much of the community is around that, I don't think that will go away. It's a weird language that will drive you to madness if you're not careful. Please try this humble plugin to keep a little bit of your sanity. And I welcome all of your ideas for improvements, contributions, and pull requests. I think we have time for questions, if there are any. Yes, I will. And the slides will be online soon-ish, with all the links to those other plugins and articles I mentioned. They're at the end after the thank you slide. Yes?
How did you, I saw that you contributed to the Golang project. How did you kind of get into like Go and all of this other, like non-C languages?
Okay, so the question was, how did I get into the non-C language reverse engineering? It's a fun story. So my work is mostly reverse engineering, and we started getting more Golang samples a few years ago. Nobody had touched any, but I had done like 2 CTF challenges that were Golang, so I was the expert by default. And so they all went to me, and I had to learn. And as I learned, I got better, so they kept coming to me, and that's all. Nim was sort of similar case, but it was because it was a group that I was tracking. Any other questions? Yep.
What kind of limitations do you see because of the usage of Nim, like they would chose a different language, they might be able to use more packages for communication or encryption. Do you see any like key limitations in the threat use of Nim?
All right, so do we see any limitations in the threat actors' use of Nim? Yes, it's not, the package ecosystem is not as mature as you would get for Python or other languages. It's also, like it's a fairly clean binary that you get as an output. So for me as a reverse engineer, it's not such a nasty language compared to some others like Rust or, well, Golang, now I'm quite fond of it, but not everyone is. So the package ecosystem is not that mature. The tooling also, I mean, it's there, but to write Nim, you have some tooling, but it's also not as widely used and widely developed as other languages. But it seems to be a well-designed language for that. It seems to really fit with that kind of use case. Anything else? All right, so this is all the places you can reach me. And I will be putting those slides online. I will be at the party afterwards. Thank you.